quietly under the stars and science slips into something a little more comfortable. Tonight, we're opening a sleepy doorway to one of humanity's most persistent dreams, a question whispered across centuries, from candlelit studies to pixel-lit bedrooms. It's a question that tickles imagination and teases the edge of science. Is time travel possible? Could we ever slip backward into yesterday or fast forward into the great unknown? Could we visit ancient empires or catch a glimpse of a tomorrow not yet written? And if we could, would we? But before we unravel space and time like an old tangled scarf, let me ask, where are you right now? Not just in place, but in time. Is it evening where you are? Is the day just winding down? Or maybe you're somewhere between clocks, caught in the soft stillness that doesn't quite belong to any hour. If this journey offers you a little peace, or simply a gentle way to close your eyes and drift, I'd be ever so grateful if you gave this video a like and perhaps subscribed. It helps this quiet corner of curiosity reach others who might need it too. So settle in, let your thoughts stretch out and soften, because tonight we're not just asking if time travel is possible, we're letting the question take us somewhere. Time travel in its simplest form might begin not with a machine or a black hole, but with something far quieter, a thought, a memory, a dream that lingers just long enough to make you wonder if you were just somewhere else, in some other time, before you opened your eyes. Because if we're honest, our minds have been time traveling all along. You've felt it, haven't you? That moment when a single scent, an old book, a certain shampoo, the first crisp air of autumn, carries you decades back in the blink of a heartbeat. Suddenly you're 12 years old again, standing in your grandmother's hallway, or walking to school, or laughing in a kitchen you haven't seen in years. Nothing around you has changed, and yet, there you are. It's not just nostalgia, it's transportation. Psychological time travel. The kind we perform without circuits or coordinates. The way our brains dip into the past or leap toward imagined futures, sometimes so vividly that our bodies react. A tight chest, a racing heart, a full-body smile. No DeLorean needed. We time travel when we remember. We time travel when we imagine. We even time travel when we regret. And curiously, our brains treat these journeys almost the same way. Studies using MRI scans have shown that the parts of the brain responsible for recalling the past are strikingly similar to the ones we use to picture the future. In both cases, we're pulling from the same messy filing cabinet, rearranging details, recombining pieces, and trying to build a coherent scene, like cutting up old photographs and layering them into a dream. So maybe the first kind of time travel is the kind we do with our eyes closed. And maybe the future we see when we worry or daydream isn't entirely fiction. It's stitched from scraps of reality after all. Children in particular live in an entirely different version of time. For them, hours stretch like warm molasses. A week can feel like a lifetime. The promise of a birthday party 3 days away might as well be written on the other side of the moon. And then there are dreams, those strange private films that play behind our eyelids. Time inside a dream can be astonishingly elastic. What feels like an entire afternoon chasing shadows or flying through a city made of mirrors might, on waking, turn out to have lasted only a few minutes. In one famous sleep study, researchers asked lucid dreamers to signal with their eyes during REM sleep, a clever workaround since the rest of the body is paralyzed while dreaming. They gave the dreamers a task: count to 10 inside the dream, then move their eyes left to right. What they discovered was fascinating. The time it took to count inside the dream was almost identical to the time it would take while awake. Dream time isn't chaos, it has rhythm, it plays by rules, just not the ones we're used to. And when you think about it, every night we slip into a kind of personal time warp, one where we forget who we are, leave behind our daily timelines, and drift through stories that often feel more real than the ticking of the bedside clock. Is that time travel? Not in the scientific sense, but in the felt sense, perhaps. There's also the way emotion distorts our sense of time, and time, in turn, seems to play along. An hour in the dentist's chair can feel like a lifetime, but an entire day spent in laughter, in joy, in love, can pass like a sigh, and afterward those memories shine so brightly that they feel bigger than they were, as if time bent around the moment to make space for its importance. Psychologists have studied this too. They call it time perception, and it's an ever-changing lens coloured by mood, attention, novelty, and familiarity. A minute can stretch or vanish depending on where your focus lies. Think of a roller coaster, how the long, slow climb fills you with anticipation, how each second clicks loudly, echoing inside your chest, and then the drop, a scream, a blur, a rush, gone before you can catch your breath. Same ride, different time. Our minds are terrible clocks, but they are exquisite storytellers. Even anticipation, that quiet ache we feel while waiting, is a kind of forward-looking time travel. The way your mind reaches ahead, rehearses what might be, plays out dozens of scenarios as if trying to prepare the world for your arrival. And dread works the same way. Anxiety really is just involuntary time travel to an unwanted tomorrow. But perhaps the most magical form of time travel we experience happens in conversation, when we tell a story, when someone leans in and listens, because in that moment you are two people sitting in the present, but you're also there, wherever the story takes you. A beach in 2007, a high school cafeteria. That night when the lights went out and the stars came pouring in like spilled diamonds, you both travel, you share a space that no longer exists, and yet it does, for as long as the story lives. We carry time inside us, in scars and songs, in the way we reach for a hand before we even know it's gone, in the ache of a song we haven't heard in years, in the shape of a name we only whisper in dreams, and none of it obeys the laws of clocks. So maybe time travel doesn't start in a lab, or with a particle accelerator, or a twist of quantum math. Maybe it begins, as so many things do, with memory, or longing, or love. Before science can tell us how time travel might work, we must first admit that part of us is already doing it, every day, every night, sometimes without realizing it, moving backward into memory, forward into hope, sideways into imagination. The real mystery might not be whether time travel is possible, it's whether it ever stopped. Long before physicists filled blackboards with equations and dreamers filled novels with wormholes, humanity was already slipping through the folds of time, not with machines, but with myths. The idea that we could move through time, not just forward in the usual way, but backward, sideways, even outside of it entirely, is ancient. It's not new. It's not even modern. It's something we've been whispering about for as long as we've had stories to tell by firelight. In the Mahabharata, an ancient Sanskrit epic from India, there's a tale of King Kakudmi, who travels to the heavens to speak with the god Brahma. When he returns, he finds that many ages have passed on Earth. Everyone he knew is long gone. The world has changed. And though he was gone for only a moment, perhaps two, time, in its quiet cruelty, has rushed on without him, a different kind of time machine. In Japanese folklore, there's the story of Urashima Taro, a fisherman who saves a turtle and is taken to an underwater palace. He spends what feels like a few days there, basking in wonder and hospitality, only to return and find that centuries have passed. His home is gone, his name is forgotten. The world he knew has vanished like sea foam. Time again plays its trick. These stories are thousands of years old. They predate relativity. They predate clocks. And yet they echo the same feeling we explore today. The unsettling notion that time is not fixed, that it may not treat everyone the same, that what feels like a moment in one realm may be centuries in another. In Norse mythology, time is wound up in the roots of the world tree Yggdrasil, where past, present and future intertwine like serpents in the dark. The Norns, mysterious weavers of fate, sit at its base, spinning the threads of every life. and in their loom, time isn't linear. It loops, it folds, it knots itself around prophecy. For the ancient Greeks, time had two faces, Chronos and Kairos. Chronos was the stern keeper of hours, the ticking, relentless time of calendars and clocks. But Kairos was different. He was the god of the opportune moment, the pause between heartbeats, the perfect instant to speak, to act, to change your fate. Kairos doesn't count time, he listens for it. And maybe, in that distinction, we find something timeless. A recognition that time isn't always something we measure. Sometimes it's something we feel, something we fall into. Even in the Bible, in the book of Joshua, there's a moment when time halts, when the sun stands still in the sky so that the Israelites can finish a battle. A celestial pause, a suspension of the world for a single purpose, a divine form of time control. Ancient China offers us the legend of the Yellow Emperor, who once travelled to a distant mountain realm to study with the immortals. After a period of what he believed to be a short spiritual retreat, he returned home, only to find that centuries had gone by. Once again, the world had spun past him. Life had moved on. Time had not waited. These stories, from cultures separated by oceans and millennia, all speak the same quiet truth. Humans have long sensed that time is not what it seems, that it's not always fair, that it slips and surges, disappears and returns, that it bends for some and breaks for others, and often it does so through dreamlike mechanisms, sleep, gods, magic, silence. Somewhere deep down, perhaps we've always felt that time has weak spots, thin places, soft walls where you might slip through if you're quiet enough or desperate enough or lucky enough. In early medieval folklore, there are tales of people falling asleep under hills or in caves or at sacred trees, only to wake up and find the world changed. Time moves differently in the fairy realm, they said. A night there could cost you a lifetime here. The Celts believed in the other world, a place outside of ordinary time. It was neither heaven nor hell, just elsewhere. Time there was slow and heavy, like honey, or else it spun in a blur. In either case, coming back meant coming back to a world that had forgotten your name. Even rituals around time suggest that we've tried, over and over, to make peace with its mystery. New Year's celebrations, leap days, calendars that try to capture lunar rhythms, sundials and shadow stones. Ancient people often treated time as a living thing, something that could be honoured, appeased, or even fooled. In some Aboriginal Australian traditions, there's the idea of dream time, a sacred era outside of linear time in which ancestral spirits shape the world. It's not long ago exactly. It's still happening. It's always happening. A timeless time, a continuous now. The Hopi people, too, have no verb tense that clearly separates past, present and future. Instead, their language describes whether something is manifested or unmanifested, known or unknown, not when it happened. In this worldview, time isn't a line, but a kind of breath. It expands, it contracts. It's not ahead or behind, it's within. And then there are idioms, tiny linguistic fossils of how cultures think about time. In English, we spend time. We lose it. We race against it. We treat it like money or a highway. But in Aymara, an indigenous language of South America, the future is described as behind you, and the past is in front. Because the past is known. You can see it. But the future is hidden. Different metaphor. Same question. Where are we in time? And which direction are we facing? Even music, especially music, plays with time in ways that make us feel transported. A slow song can stretch a moment. A single repeated note can feel like falling backward. A sudden key change can break time entirely. Musicians have always been time travelers, guiding our emotions through rhythm, delay, echo, and of course there's storytelling. Perhaps the oldest form of time travel we have. To tell a story is to rearrange time, to leap across years in a sentence, to pause a single moment and expand it into pages, to skip, rewind, fast forward, all with words, all inside the mind. A grandmother tells a child a story from her own childhood. The child listens, and for a moment 2 timelines blur. 2 versions of time, the lived and the told, exist at once, and so it goes. Across cultures, across histories, the idea of stepping outside of time has always lived in us. Not as an equation, not as a paradox, but as a longing, a quiet wish to revisit, to repair, to glimpse what might have been. We've wanted to rewind the clock for as long as we've had the clock, or rather, since we first realized it was ticking. Before time travel was a theory, it was a metaphor, a myth, a way to talk about love and loss and the unbearable speed at which things change. And maybe that's why it still captures us, because even if we never invent a time machine, the desire to change time or outwit it, or at least understand it, feels deeply human. You could say that the real history of time travel doesn't begin with Einstein, or H.G. Wells, or science fiction. It begins in the first moment someone looked at a sunrise and wished they could make it last. The first time someone said, just a little longer. The first time someone wondered, what if I could go back? If myths gave us time travel in dreams and legends, physics brings it into the light, blinking, curious, and far stranger than any bedtime tale. To begin, let's leave behind the idea of shiny machines or swirling portals, and instead ask a quieter question. What exactly is time? To a physicist, time is more than a ticking second hand. It's a coordinate, a dimension, like up or down, left or right. It's the 4th dimension in a universe that insists we don't just live in space, but in space-time. It was Albert Einstein who wove this idea together, space and time as threads in a single, stretchable fabric. If you place something heavy on that fabric, like a planet or a star, it bends. And when the fabric bends, so does time. This is not metaphor, it's measurable. Time runs slower in the presence of mass. If you set 2 clocks, one at sea level, the other on a mountaintop, they will tick at slightly different rates. The one higher up, farther from Earth's gravitational pull, will run just a bit faster. A few billionths of a second faster per day, but still faster. This strange truth is called gravitational time dilation, and it's real. We've measured it with atomic clocks so precise they could spot a difference caused by standing just a few centimeters higher. So the question is no longer does gravity affect time, but rather how much? And what happens when you take that idea to its extreme? Imagine a black hole, a collapsed star so dense its gravity pulls not just light, but time itself inward. Near its edge, the event horizon, time begins to stretch, slow, drag like syrup on a cold plate. To a distant observer, anything falling into the black hole appears to freeze in time, caught at the edge forever. But for the falling object, time feels normal, steady, ordinary. This is one of the strange gifts of relativity, the idea that time is not universal. It doesn't tick at the same speed for everyone. It's personal, dependent on where you are and how fast you're moving. It means that your watch, your heartbeat, your very perception of now can drift from someone else's, and that opens a door. Because if time can stretch and slow and bend, might it also loop? Might it double back on itself? Might it allow, in some rare, carefully constructed place, a traveller to move not just forward in time but backward? Maybe. Let's not jump too far ahead. First, we have to explore speed, because gravity isn't the only thing that changes time. So does motion. In Einstein's theory of special relativity, the faster you move, the slower your time flows compared to someone standing still. If you could build a spaceship fast enough, almost as fast as light, you could travel for what feels like a few years and return to Earth to find that decades have passed. It's called time dilation, and it's not just a thought experiment, we've tested it. Astronauts aboard the International Space Station age very slightly slower than we do on Earth. Not enough to notice, but enough to measure. Their clocks, their cells, their lives, all shifted just a touch into the future. It's not science fiction, it's science. Time travel, forward, through velocity. But what about going back? What about winding the clock in reverse? This is where the theories become trickier, and the universe far more reluctant. In 1949, the mathematician Kurt Gödel, yes, the same Gödel who shattered logic with his incompleteness theorems, presented a solution to Einstein's equations that described a rotating universe. In such a universe, Gödel showed, time loops were possible. You could travel a path through space-time and return to your own past. The mathematics checked out. The implications did not. It suggested a universe with no clear now, where yesterday and tomorrow could blur, and where cause and effect might tangle like headphone cords in a pocket. Theoretical physicists have since proposed other models, closed time-like curves, wormholes, and cosmic strings. Each offers, on paper, a possible route through time. Each carries a heavy load of conditions, warnings, and unresolved paradoxes. Wormholes are perhaps the most famous. Picture space-time as a vast sheet of paper. You draw two dots, A and B, far apart. Normally, to travel between them, you move along the surface. But what if you could fold the paper, bring A and B together? Poke a hole, step through. That's a wormhole, a shortcut through the fabric of reality. If one end of a wormhole could somehow be accelerated, say, moved near a black hole and brought back, it would experience time differently than the other, step through one end, and emerge in the past. Elegant, tempting, terribly unstable. Wormholes, if they exist, would likely collapse instantly. To keep one open, you'd need negative energy, an exotic form of matter with properties not yet observed in any reliable way. Still, the math allows it. The universe doesn't slam the door shut. It just places enormous locks on it and hides the key under several layers of impossible. So we're left with a tension. On one hand, the laws of physics, especially Einstein's, don't forbid time travel outright. They offer paths, narrow ones, dangerous ones, but paths. On the other hand, we find no evidence that such travel occurs. No time tourists, no closed loops in our biographies, no rewinding of broken moments. It's as if the universe permits time travel in theory, but refuses it in practice. Maybe the laws are incomplete. Maybe we're missing something. Something buried deep in quantum gravity, or hidden within the mysterious relationship between entropy and time's arrow. Or maybe, and this is a possibility physicists take seriously, time travel is simply too delicate, too complex. The universe allows it, but only under conditions so extreme, so precise, that no civilization, no matter how advanced, could build or survive the journey. Still, the idea remains, like a light in the distance, like a star that's already burned out, but whose glow hasn't yet reached us. Maybe we can't go back, but maybe, somewhere deep in the equations, is the memory of the universe that tried. If time truly bends, then perhaps our questions must bend with it. Because for all the elegance of physics, time travel remains wrapped in riddles. Not just technical ones, but logical ones. Soft paradoxes that unravel when you try to thread your way backward. Let's say, for instance, that someone builds a time machine. Just one. It works. There it is, humming quietly in a lab, blinking with the promise of possibility. Someone climbs inside and goes back in time, and changes something. Maybe something small, a misplaced cup, a forgotten note, a word left unsaid. Or maybe something large, a catastrophe averted, a life saved, a decision unmade. And yet, if the past is changed, what happens to the future they came from? Does it blink out of existence? Do they cease to be? This is the core of what's known as the grandfather paradox. The idea that altering the past could erase the very conditions that made your trip possible in the first place. It's like building a ladder and kicking it away mid-climb. So how does the universe handle that? Some theories suggest it doesn't, that it can't. That nature has a kind of built-in resistance to paradox. A quiet rule that says, you can visit the past but you can't change it. Not meaningfully, not in ways that would disrupt causality. This idea is called the Novikov self-consistency principle, and it's oddly comforting. It suggests that time might loop but never break. That history might bend around you like water, flowing to preserve the shape of things. You can be there, you just can't edit the script. Others have proposed a different answer. The many worlds interpretation, drawn from quantum mechanics, suggests that every possible outcome of every event splits the universe. Each decision branches. Each moment fractures into infinite versions. In this view, changing the past doesn't erase your present. It just creates a new one, a separate timeline, a forked path. You return to a world where things are different, but it's not the world you left. It's a neighbour, a sibling, a fresh story with its own rules. In that case, time travel is not rewinding the tape, but switching tapes entirely. And then there's another idea, quieter, stranger, one that doesn't involve wormholes or paradoxes or infinite realities. It's this. Maybe time travel is happening all the time, right now, just very, very slowly. Because in a sense, we're all moving through time, always forward, 1 second per second, a steady drift across the surface of space-time. What's missing isn't motion, it's control. We can't skip ahead. We can't double back. We can only ride the current. And yet, what if we could change how that current flows? Already our bodies know this intuitively. We've built machines to stretch time, slow-motion cameras that break seconds into splinters, letting us see a hummingbird's wing mid-beat. We've created time-lapse videos that make flowers bloom and cities grow in minutes. We've extended memory, writing, photographs, recordings. We preserve the past like fossils, like amber. Each snapshot a portal to a moment we no longer live in, but can still return to, if only in mind. We've even begun to nudge biology, extending lifespan, studying telomeres and cellular clocks, asking quietly if aging itself might one day be softened, or at least slowed. Is that time travel? Not in the cinematic sense, but perhaps in a more personal one. Because what is time travel really, if not the ability to move through moments on our own terms, to hold on to the ones we love, to linger in joy, to outrun grief? And while physics may offer us wormholes and equations, it also humbles us. It reminds us that time is not ours to command, that it has rules and rhythms and secrets still folded deep in the fabric of the cosmos. Scientists continue to search. They build particle accelerators, launch satellites, run simulations. They study time's flow, its asymmetry, its entanglement with space. They whisper questions into the void, and sometimes the void answers back, through light, through gravity, through equations that hint, just barely, at what might be possible. But for now, time travel remains at the edge of knowledge, a maybe, a not yet, a flicker in the corner of the cosmic eye. Still, consider this, the fact that we can even ask the question, that our minds can imagine stepping outside the river of time, that we can build models, theories, dreams, all reaching for something just beyond the veil. That in itself is extraordinary. We are creatures bound by time, and yet obsessed with escaping it. We measure, we mark, we mourn, and we wonder. Not just because we want to go back, or forward, but because we want to understand the thing we live inside of. Time travel, in the end, may not be about moving through history. It may be about listening, deeply, to the nature of time itself. If time travel is possible, even just a sliver of it, then the road forward winds through the strange and tangled hills of modern physics. This is no longer the domain of myth or metaphor. It's equations, experiments, hypotheses that read like poetry, even when wrapped in math. Tonight we're going deeper, into the folds of time, into the places where things start to slip, not just in theory, but in the very logic we use to define what a moment even is. Let's start with motion, and with it, a paradox. Time dilation, as we've explored, tells us that the faster you move, the slower time passes for you compared to others. This isn't just an odd footnote in relativity, it's central. It means that time isn't fixed like the tick of a clock on a kitchen wall. It stretches, slows, curls up in your pocket. But here's where it gets strange. The closer you get to the speed of light, the more dramatic the effect becomes. Imagine a spacecraft travelling at 99.9% the speed of light. Inside, everything feels normal. You sip tea, you stretch, you yawn. But to someone watching from Earth, your clock ticks slower and slower. You're aging slower. Not metaphorically or biologically. If you travelled far enough, fast enough for what felt like 2 years, you might return to find a century gone. Loved ones aged, cities transformed, languages shifted. Your home planet would be a future version of the one you left. Forward time travel via velocity. Now imagine this on an even larger scale. Let's say a civilization manages to create a near light speed train, a sleek ribbon of physics, orbiting a planet for what feels like a decade. They could return to their homeworld to find that thousands of years have passed. Wars fought, ice ages come and gone. Entire histories written in the space between departure and return. This is called relativistic time travel, and while we're far from building such a machine, the physics behind it is solid. The math holds. The predictions match observation. But this only gets us in one direction, forward. So let's turn around. Let's peer, quietly, into the shadowy idea of going back. For that, we need to visit something even stranger. Closed time-like curves. Imagine space-time not as a flat sheet, but as a surface that can be bent into loops. A closed time-like curve is a path through that loop, one that circles back to its own past. Travel far enough along it, and you could, in theory, arrive before you departed. It's not fantasy. It's math. These curves are solutions to Einstein's equations. They exist, at least on paper. And yet, they unsettle the logic we live by. Because if you can go back, can you undo? Can you change? Can you prevent your own journey? Or worse, could you cause it? This opens the door to what physicists call causal loops. Situations where an event is both the cause and the effect of itself. Let's say you invent a time machine after years of work, but then one day someone appears, older, wiser, familiar, and hands you the blueprints. You follow them, build the machine, then go back in time to hand them to your younger self. Where did the idea come from? Who created the original plans? This is called a bootstrap paradox, a loop of logic without a clear beginning, and yet it fits the mathematics of time travel, uneasily, elegantly, unnervingly. Some physicists argue that causal loops could exist, as long as they're self-consistent, as long as they don't introduce contradictions. You can go back, but you can't break anything. You're not a vandal in history. You're part of the story, always have been. Other scientists, though, are less convinced. They point to entropy, the idea that systems tend toward disorder over time. Reversing time would require reversing entropy, unburning ashes, unscrambling eggs, restoring chaos into order, and that, they say, is deeply unlikely, not impossible, just profoundly improbable. Still, theoretical models press on. Some propose rotating black holes, also known as Kerr black holes. These swirling giants don't just pull time downward, they twist it. Near the ring-shaped singularity at their centre, space-time may fold into strange shapes. Some speculate that a traveller might, in theory, orbit the singularity and emerge in the past, but the path would be perilous, filled with deadly radiation, surrounded by forces strong enough to rip atoms apart. No shield could survive it, no spacecraft could navigate it, no heartbeat could endure the pressure. It's not just a technical problem, it's existential. Even if a path exists, could anything walk it? Then there's the idea of tachyons, hypothetical particles that always travel faster than light. If such particles exist, their timeline would be reversed from ours. What we call effect, they might call cause. Their future might be our past. But so far, no tachyon has ever been detected. They remain for now ghosts in the map, suggestions, dreams. And what about quantum physics? That's a story in itself. One will unfold soon enough. But even here, time behaves strangely. In some interpretations of quantum mechanics, particles don't follow a single path through time. They explore all possible paths at once, then settle on one when observed. This behavior, called the path integral formulation, implies that the future and the past are linked. Not rigidly, not predictably, but entangled in a quiet web of probability. Some physicists even suggest that quantum entanglement, the spooky action that Einstein himself found unsettling, might be a form of non-local communication through time, not messages, not memories, just correlation, strange, precise, instantaneous, a kind of quantum déjà vu. And yet, through all of this, we've never seen a true time traveller, not one. No mysterious visitors at turning points in history, no versions of ourselves stepping through shadows, no hints of histories written in reverse, which leaves us wondering, if time travel is possible, where are they? Some say they're hiding, that advanced travellers from the future are simply discreet, observing without interfering, scientists in disguise, tourists with rules. Others argue that time travel can only begin after the invention of the machine, that you can't travel to a time before the tunnel existed. Still others suggest that the universe protects itself. That causality is sacred. That paradox is forbidden not by ethics but by physics. It's not that you shouldn't change the past. It's that you can't, not because you lack will, but because the timeline is already sealed. You can only play your part. And if you travel back, perhaps you already did. Let's now turn the lens inward. Because while physics builds machines out of mathematics, the deepest mysteries of time travel may lie not in distant stars or impossible speeds, but within the workings of the human mind. The brain, after all, is a time machine of its own kind. A few cubic inches of soft grey matter, and yet inside, we replay moments from decades past, imagine futures that haven't yet happened, and sometimes even mistake one for the other. You close your eyes, and suddenly you're 6 years old again. You're 22 and nervous. You're holding a hand that hasn't touched yours in years. It's memory, yes, but also more than that. But neurologists call this mental time travel, and they mean it quite literally. Our brains have evolved not just to recall events, but to simulate them, to re-experience them. We don't just remember, we revisit. And curiously, the same brain regions used for remembering the past are used for imagining the future. The hippocampus, the medial prefrontal cortex. These are your internal navigators. They help you leap from one moment to another, stitching scenes together like frames in a film reel. But there's a catch, because even as we travel mentally, we're limited physically. Locked into the arrow of time, the great forward sweep. That arrow, the one-way direction of time, seems to emerge from something called entropy. In physics, entropy is a measure of disorder, of randomness, of how spread out energy becomes over time. It's the reason a sandcastle crumbles, but never spontaneously reassembles. Why your hot coffee cools, but never heats itself back up. Why we grow older, not younger. The second law of thermodynamics tells us that in a closed system, like, say, the universe, entropy tends to increase. Systems become more disordered, and that increase gives time its direction. It's not a force, not a clock. It's a tendency, a flow, a bias in the universe toward messiness. Some physicists believe this is why we can remember the past but not the future, because memory, at a cellular level, requires creating new structures in the brain. It leaves a trace, and you can't leave a trace of something that hasn't happened yet. In other words, the past has entropy patterns. The future doesn't. Not yet. But here's where it gets weirder. On the tiniest scales, down in the strange world of quantum mechanics, the equations don't care about direction. Run them forward or backward, and they work just the same. Time has no arrow there, only possibility. So where does the arrow come from? One idea is that it's not fundamental, that it's emergent, a kind of illusion that appears only when large systems like us observe smaller ones like particles. We don't see the fuzziness, we see the pattern, the story, the timeline. Another idea, more cosmic, is that the universe began in a state of astonishingly low entropy. Right after the Big Bang, everything was uniform, ordered, a blank canvas. And from that strange moment of high symmetry, entropy began to rise. Stars formed, galaxies spun. Time began to flow, not because of clocks,